Assalamu alaikum, my dear students. I hope all of you are fine and doing well. The topic that we will discuss today it is the oxides of alkali and alkaline earth metals. So here we will react basically the oxygen with the alkali and alkaline earth metals, or we will discuss about the products when the oxygen just reacts with the group 1A and the group 2A elements. So, what will be the products and what will be the nature of these products? Let's have a look on this. So, basically, the oxides of alkali and alkaline earth metals, it may be of two types. They may be of basic in nature or they may be of acidic in nature. All that just depends upon the reason that what type of products they are going to form when they react with the water or the other substances. So in this lesson we have to just look on the simple oxides of alkali and alkaline earth metals. So the first one we have the oxides of alkali metals. In a simple way, when we have a look on the oxides of alkali metals, all the alkali metals just reacts with the oxygen and they produces their respective oxides. The first one, remember, here we have lithium oxide. It produces the oxide which is normal oxide. On the other hand, when sodium it reacts with the oxygen, it produces the oxide which we call it as the peroxide, and peroxide's formula is Na2O2. On the other hand, potassium oxide it produces the oxide which is called as the superoxide. And lithium also reacts, they produces their hydroxides. As they are producing the hydroxide, it means they are highly basic in nature. As they are basic in nature, it means they produces bases when get dissolved in water. And this basic in nature represent that their oxides are mainly basic. So all the metals that reacts with the oxygen, they produces the oxides and their oxides are mainly basic in nature. And what is the trend of this basicity when we move from top to bottom in the group 1A. So the group 1A, first one element we have lithium and the last one we have then sodium, potassium and so on. We have rubidium, cesium and francesium. From top to bottom moving, their electropositive character increases. Electropositive character increases. As their electropositive character increases, it's mean their basic character also increases. Basic nature or the basic character also increases. What is the reason behind this? Because they can lose their electrons easily and they changes into the metallic oxides in no time and they will in turn be basic in nature. So down the group their basic character increases. So that's why the potassium is forming a superoxide as compared to the lithium oxide which is forming the normal oxide. On the other hand, when this superoxide or the simple peroxide of potassium we have K2, it reacts with the carbon dioxide, it produces potassium carbonate along with the oxygen. So this potassium carbonate is mainly producing the oxygen gas along with it at the same time. So it is very interesting to know that when we are using the breathing equipments for the mountaineers, it may contain the potassium dioxide along with this. So down the group, their basic character increases. Next, we have the oxides of the alkaline earth metals. Basically, the oxides of the alkaline earth metals are also basic in nature. Why they are basic in nature? Because they when they get dissolved in water, they produces bases or alkalis. And we have beryllium, magnesium, calcium, strontium, and barium. They react with the oxygen and produces their respective metal oxides. So their basic character of alkaline earth metals also increases down the group. It also increases down the group because their electropositive character increases. As their electropositive character increases, their size also increases. When their size increases, mean they can lose the electrons easily, and when they can lose the electrons easily, in turn they changes into the metal cations, and now these metal cations can react with the water and produces the respective hydroxides. So that's why they are basic in nature, or they are alkaline in nature. But on the other hand, when we have a comparison between the group 1A and the group 2A elements, so which one will be the more electropositive? So group 1A element will be more electropositive as compared to the group 1A. This is less electropositive. And the simple reason for this is because they can lose their electrons more easily, they have less ionization energy, and they have more ionization energy. Along all the oxides of alkaline and alkaline earth metals, there are some oxides which are amphoteric in nature, and alkaline earth metals have a oxide which is beryllium oxide. It is amphoteric in nature. It means it can react with both acids and bases. And here we can have its formula. We have beryllium oxide when it reacts with the sulfuric acid. Then the products we have, it is beryllium sulfate plus water. It produces salt in water. On the other hand, when we have beryllium oxide and it reacts with the base, that is sodium hydroxide, then the product we gain, it is the salt of sodium and water. So in both it produces the salt and water. So beryllium oxide acts basically amphoteric in nature. Amphoteric mean that is having both the properties of acids and bases. So this was a simple overview about the oxides of alkaline earth metals. I hope you guys understand, and if you have any queries you may ask me about that. And the next topic that we will discuss, it is the hydroxides and carbonates of group 1A and group 2A elements. For that time you guys keep learning and have a good day.